right now, like at this very moment, about 25% of the manufacturing workforce is basically packing up their desks. They're taking, maybe 30 years of hard-earned muscle memory, and they're just walking out the door into retirement.
Yeah, it's a phenomenal demographic shift.
Yeah.
We are literally watching a whole generation of unparalleled physical expertise just, well, evaporate.
Evaporate, right.
Yeah.
Because they aren't writing down how they do their jobs before they leave.
Exactly. And for any enterprise that really relies on complex physical operations to function, this isn't just a transition. It's an existential threat.
It is. And, to put some hard numbers to that threat for you, we looked at the World Economic Forum's Future of Jobs 2025 report. They found that 63% of employers say the skills gap is their absolute #1 barrier to transformation.
Which makes sense, right? Because when a master technician retires from, say, an oil refinery or a manufacturing plant, their expertise doesn't just get boxed up and put in the storage closet.
Right, it's gone.
Because the deepest expertise in these companies, it doesn't live in a manual, it doesn't live in a database. It literally lives in people's hands.
Which, honestly, brings us to our mission for this deep dive. Today, we are unpacking a brand new white paper and a press release from EON AI Ventures, and they're based out in Irvine, California.
Yeah, and what they're proposing is massive.
It really is. They're proposing a completely new category of enterprise system called Work Intelligence, or WI.
Yeah.
And it's designed specifically to capture that human muscle memory before it leaves the building for good.
Right.
Okay, let's unpack this. Because we have software that tracks our money, our customers, and our product designs. But tracking how a master mechanic actually fixes a turbine, that's like having a perfectly organized kitchen inventory, but zero recipes for the actual food.
I love that. That analogy hits the nail right on the head.
Yeah.
Because there's a concept from the philosopher Michael Polanyi, which is cited in the source material, that really, I think, grounds this entire problem.
Oh, the Polanyi quote, yeah.
All right, he said, "We know more than we can tell."
We know more than we can tell. That makes perfect sense when you think about physical labor, actually.
It does. And, it explains exactly why this crisis has been so difficult for technology to solve up until now. Because we have artificial intelligence today that can pass a bar exam, right? Or write a brilliant essay.
Or code a whole website in 10 seconds.
Exactly.
Yeah.
But it cannot run an oil refinery. It cannot commission a manufacturing plant. And that's because physical knowledge is what we call tacit.
Tacit knowledge, right.
Yeah, it relies entirely on feel, on situational judgment, on tiny microscopic corrections that a worker makes in the moment.
So, if a standard operating procedure says, I don't know, tighten the valve, the master technician knows you actually tighten it until you feel a very specific vibration in the wrench.
Yes.
Because if you don't, the pressure seal blows.
Yeah.
And you can't put a vibration into a PDF document.
You really can't. And because traditional software relies on explicit data, we have to kind of look at how past technologies have just failed to capture this tacit knowledge.
Right.
There's this staggering historical shift that the white paper points out, which really sets the stage here. If you look back at 1975, intangible assets made up about 17% of an enterprise's value.
Okay, wait. So in the 70s, 80+% of companies' value was purely physical stuff, like the factories, the machines, the inventory sitting on shelves.
Exactly. But today, that number has completely inverted. Roughly 90% of enterprise value is now intangible.
90%.
Wow. But here's the kicker. The absolute most critical part of that 90%, the actual operational competence of how the physical work gets done on the floor, has never been capturable.
It's literally just walking around in people's heads.
Right. And until now, every digital approach to solving this has fallen into what we can call the text trap.
The text trap.
Yeah, software companies tried to flatten three-dimensional physical work into two-dimensional text. So, for example, a modern AI might look at an image or like a video of a worker assembling a motor, and it just writes a text description of what they're doing. It generates words about the work.
Okay, wait, I need to push back on that for a second. Because camera technology and machine vision are just unbelievable right now. Isn't a really detailed text log combined with, say, a 4K video recording enough?
You'd think so, but
I mean, if I watch a high-def video of a master plumber fixing a complex pipe system from 3 different angles, shouldn't a sufficiently advanced AI be able to figure out the process from that footage?
it's a really logical assumption. but it completely misses the core differentiator of EON's entire approach. Flat video and text logs fundamentally lack what we call contextual fidelity.
Contextual fidelity. Break that down for me. What does that mean?
So think about what a video actually is. It's just a sequence of flat pixels, right? It shows what happened from a single perspective. But the software looking at those pixels doesn't understand the depth of the room.
Right, it's just a 2D image.
Exactly. It doesn't understand the spatial geometry of the pipe or the physical properties like weight and gravity of the components themselves. It's observing a picture, but it's not comprehending the environment.
Oh, I see.
So EON's approach is to turn the work not into text, but into a world.
A world, like a fully simulated virtual environment.
Yes, a living, interactive, 3D digital twin. In this system, the knowledge is embedded directly into the digital space itself. The geometry and the components have actual physical rules attached to them.
So it's not just a drawing. It acts like the real thing.
Exactly. So when a worker does something out in the real world, it isn't summarized into a text file. It's captured into that 3D world with full contextual fidelity.
Oh, wow.
Yeah, the system actually knows the exact angle of the wrench where the worker's arm moved in 3D space and exactly how the component reacted to that movement.
That is a massive leap from an AI just, writing a summary of a video clip. But that naturally leads to a huge logistical question for me.
Go for it.
How is this 3D world actually built? Because if you told me I had to build a physics-accurate 3D simulation of an entire operating oil refinery, that sounds like a decade-long project with a small army of developers.
Well, 10 years ago it was.
Yeah.
And that's exactly why EON notes in the white paper that they have been working toward this specific architecture since 2018.
Oh, so they've been at this a while.
Yeah. They recognized early on that the surrounding technology just wasn't mature enough yet. But today, they've managed to combine 4 specific technological breakthroughs into a single, continuous closed loop.
Okay, so let's explore the mechanics of this loop. If we aren't hiring an army of 3D modelers, how does the initial simulation even get built?
The foundation of this loop is a system they call Genesis. This is the breakthrough that actually builds the twin.
Okay.
Instead of humans spending months and, 6 figures manually creating a simulation in CAD software, AI now automatically generates an intelligent 3D twin of the environment.
Just automatically.
Yeah. And crucially, it's not just a visual skin. It has true geometry and behavior. So if there's a digital conveyor belt, it moves, it acts, and it responds to digital physics just like a true simulator.
So Genesis instantly generates the stage, basically.
Right.
But an empty, mathematically perfect 3D environment doesn't solve the problem of capturing human intuition. If you're listening to this and you work in a heavy industrial setting, you're probably wondering how a worker actually interfaces with this virtual space while they, have grease on their hands.
That is exactly where the second part of the loop comes in, which is called field IQ. This is the connection point between the physical worker and the digital twin.
How does that work?
Workers wear smart glasses or use specialized cameras that observe the work they're doing in real time. But it's not just a camera passively recording them. It interactively guides the worker at the point of work.
Okay, so it's a two-way street.
Exactly. It's a real-time, two-way data channel between the human in the physical world and the digital twin in the virtual world.
So the worker is constantly tethered to the simulation, receiving guidance overlaid on their vision. But how does their physical, messy reality get translated back into that clean digital twin?
Through a mechanism called AssessQ.
Assess IQ.
Yeah, so as the worker performs their tasks, their movements and actions are captured and grounded entirely in spatial geometry.
What does that actually mean practically, though, spatial geometry?
It means instead of a text log being generated that just says, operator inspected the pipe at 2 p.m., the system uses depth sensors and spatial tracking to record the exact physical coordinates of the action.
Oh, wow.
Yeah, it records the arc of the worker's arm, the approach angle of the tool, the duration of the physical pressure. It is a true spatial recording that can be replayed, viewed from literally any angle in the 3D space, and simulated later.
Okay, so we've generated the environment with Genesis, we're watching the worker with Field IQ, and we're capturing their physical movements in 3D space with Assess IQ.
Right.
But that's just recording data, right? How does the system actually learn from it?
Well, that happens in the final phase of the loop, which involves their verdict system and something called compound IQ.
Verdict. Sounds intense.
It kind of is. This is where the AI takes the spatial data that just came back from the field and subjects it to adversarial verification.
Adversarial verification. That sounds like the AI is like picking a fight with itself.
Think of it exactly like 2 AI models debating. One AI model looks at a new improvised technique the human worker just used and says, hey, this is a faster, more efficient way to turn the valve. We should update our procedures.
Okay.
But the adversarial model is designed to be a strict skeptic. It runs thousands of rapid physics simulations on that new technique, trying mathematically to prove why turning the valve that way might cause a pressure leak.
Ah, so it stress tests the human's intuition in a simulated vacuum.
Yes. And if the skeptical AI fails to break it, meaning if the technique is proven to be safe and reliable, the system accepts it as a good move.
Right.
And then Compound IQ folds that new knowledge permanently back into the 3D digital twin.
Here's where it gets really interesting. That completely flips the traditional software model on its head.
It really does.
If I'm picturing this right, it's like a magical workshop. Imagine a workshop that constantly watches a master carpenter build a chair. It copies their exact hand movements into a holographic blueprint, automatically tests the math to make sure the chair won't break when someone sits on it, and once it verifies the safety, it instantly updates the official blueprint for every other apprentice in the shop.
That's a great way to visualize it. And what's fascinating here is, from a business philosophy standpoint, the white paper points out something crucial about this process. Owning just one of these breakthroughs yields a standalone product.
Right, like just the glasses.
Exactly. You could build a very successful company selling just an auto modeling tool or just industrial smart glasses. But owning the entire closed loop from generating the environment to observing the worker, capturing it spatially, and compounding the intelligence that is what defines a completely new category of software.
Which they are calling work intelligence. But as we unpack this closed loop, a glaring issue jumps out to me.
What's that?
We are talking about highly complex, high-stakes physical work. Refineries, turbines, chemical manufacturing floors. How can an enterprise actually trust an AI with safety-critical operations?
It's a huge question.
Right. Because if a chatbot writes a bad email, you send an apology. If an AI hallucinates the torque specs on a high-pressure gas line, the margin for error is literally zero. People could get hurt.
And that precision requirement is exactly what separates consumer AI from enterprise work intelligence. EON has a 25-year background in extended reality, or XR, and their core operating philosophy is built around that exact risk.
Because they know the stakes.
Exactly. Generic AI, like the large language models we use to summarize articles, might deliver 80% quality. And for a consumer app, 80% is totally fine.
Sure, I just need the gist of the article.
Right. But in high-stakes physical operations, you require 100% quality. As you said, a hallucination in a refinery is a catastrophe.
So how do they govern the system then? Because we mentioned earlier that we have software for everything else. An ERP tells you what materials you have. A CRM tells you who you're selling to.
Right.
A PLM tracks your product designs. If work intelligence is going to sit alongside those as a new system of record calculating the physics of human labor, what are the actual rules of engagement?
Well, they've established very strict operating principles for this, first and foremost. Advice, not authority.
Advice, not authority. Okay.
The AI suggests the next step, but the human expert always makes the final decision. The system assumes absolutely nothing. Autonomy is something the machine has to earn through massive amounts of verified repetition.
So it's strictly an assistant. It's never a commander.
Exactly. The second rule is that rigorous adversarial verification we just discussed with the verdict system.
Right. The AI fighting itself.
Exactly. It aggressively stress tests every digital twin and every new procedure in the simulation before it is ever trusted or deployed to the smart glasses of other workers.
And how do they track compliance? Like, how do they prove it was done right?
That's the third rule, standardized tracking. The AI-generated gold standard twin serves as the baseline specification.
The ideal way to do it.
Right. Then, a SEQ is constantly measuring the delta, so the physical difference between that perfect baseline and what actually happens in the real world.
Oh, I see.
And all of this generates a complete traceable audit trail using something called the XAPI standard.
Okay, let's define XAPI for a second. Why does that matter?
So XAPI stands for the Experience API. It's a software specification that allows different learning systems to communicate with each other.
Okay.
So instead of John tightened the bolt being a subjective human note jotted down on a clipboard, XAPI turns that action into standardized, measurable data points that can be read by the company's other HR or compliance software. It proves, mathematically, that the work was done to spec.
Okay, let me play devil's advocate here for a second because I can hear the seasoned factory operators groaning at the thought of
I'm
this.
sure they are.
If you are constantly measuring the delta between what the human does and this gold standard twin, and you're logging every single movement into an XAPI audit trail, isn't there a massive risk of the machine becoming a rigid micromanager?
It's a very fair concern.
Right. Because if the system demands 100% adherence to the baseline, doesn't that kill the very human intuition, that tacit feel we are desperately trying to capture in the first place?
That is easily the most common fear with automation. But it misunderstands how the loop actually works. The loop runs both ways.
Both ways.
Yeah. It is not just the machine dictating rigid instructions downward to the human. When an experienced human operator improvises a better, safer, or faster way to do something using that tacit feel, the system recognizes the deviation.
But it doesn't just yell at them for doing it differently.
No, it doesn't punish the worker at all. It analyzes the deviation, verifies if it's safe using the verdict system, and then it updates the twin to match the human.
Oh, wow. So the system actually bends to human expertise. It doesn't fight it.
Precisely. The core philosophy of work intelligence is that the operator owns the competence, not the software vendor.
That is fascinating. The human is actively teaching the system just by doing their job well. It's like a living library.
Exactly.
Which I guess brings us to the ultimate end game of this technology. If this living library is constantly compounding and learning from the operators, who actually gets to check out the books? Who are the beneficiaries of this captured intelligence?
Well, there are three distinct beneficiaries. The first is for the people themselves. EON refers to this as Human 2.0.
Human 2.0.
Yeah, imagine being a junior technician on your first solo shift at a power plant. Having this system via smart glasses is like placing the most experienced 30-year veteran expert right over your shoulder, guiding you interactively through the physical space.
That would be incredible for training.
It's designed to multiply the capabilities of human workers, closing that skills gap immediately on the floor.
And the second beneficiary.
The enterprise itself. EON's president, Mads Johansson, notes in the release that CIOs everywhere are basically facing the same nightmare.
The great crew change.
Right. The skills walking out the door are their biggest unmanaged risk. Work intelligence takes that massive unmanaged risk, that vanishing tacit knowledge, and turns it into an owned, measurable, and compounding asset on the company's balance sheet.
Great. It captures that missing 90% of intangible value we talked about earlier. So that solves the immediate human problem, and it solves the enterprise risk problem. But there's a third beneficiary, isn't there?
There is. And it's perhaps the most futuristic aspect of this whole initiative, even though the foundation is literally being laid right now.
Okay, I'm ready.
The third beneficiary is the machines. This system is actively building the curriculum for physical AI.
So what does this all mean? Let's synthesize this for a moment. The chairman of EON AI Ventures, Dan Ledurskar, has this incredible quote in the materials.
Yeah, it's a great quote.
He points out that enterprises have digitized everything except the one thing that actually runs the company.
Yeah.
How its best people do the work.
Exactly.
When I hear that and I think about this third beneficiary, the machines, it sounds like we are building the ultimate digital library of human physical movement, specifically to act as the textbooks for the autonomous robots of tomorrow.
That is exactly what is happening under the surface here. Think about the near future, when humanoid robots and advanced autonomous machines arrive on factory floors. They won't magically know how to commission a chemical plant or assemble a jet engine.
Right, they just have the hardware.
Exactly. They have to be taught how work is actually done in the messy, unpredictable, physical, real world.
And you can't just feed a robot Wikipedia articles to teach it how to fix a pipe.
You really can't. There is no public data set for physical labor. You can't scrape the internet to teach a robot the exact tactile pressure required to fit a specific rubber gasket.
Yeah.
The machine manufacturers will provide the physical AI, the brains of the robot, essentially. But the enterprise has to provide the work intelligence. That curriculum, the textbook for those robots, is being written right now by human hands in 3D space.
It really is a paradigm shift in how we think about human labor. I mean, we started this conversation looking at a massive, terrifying problem, the great crew change, where all this generational knowledge is just evaporating into retirement.
Right.
And the solution isn't to beg people to stay or to try and force them to write better manuals. The solution is essentially digitizing human physical competence. We are capturing the uncapturable using this 3D closed loop of generating, observing, capturing, and verifying.
It's revolutionary.
And in doing so, creating a work intelligence system that sits right next to the CRM and the ERP as the missing piece of the modern enterprise puzzle.
And if we connect this to the bigger picture, the broader history of enterprise software, you can clearly see the evolutionary arc here.
How so?
Well, for decades, companies relied on business intelligence. That technology was fantastic at telling us what happened. It could count the beans and track the resources.
Sure.
But work intelligence is entirely different. It is capturing how things actually work in the physical world. We are moving from recording flat business transactions to recording physical reality itself.
It fundamentally redefines the value of a physical worker. And, it leaves me with one final lingering question for you to ponder on your own as you go about your day.
Let's hear it.
If a company uses your years of hard-earned intuitive feel on a factory floor to train a 3D digital twin, and that twin eventually becomes the curriculum for a robot,
Wait, who really owns the rights to your muscle memory?
that is a great question.
We'll let you two on that one. Thank you so much for joining us on this deep dive into work intelligence. We'll see you next time.